Evaluating logs, some extra examples. Evaluate log base 10 of 2 plus log base 10 of 500. So we're going to use the first law of logs, which states that multiply becomes add, but we're going to use it in reverse. So we're going to change this plus to multiply. So we'll only have log base 10 once. We'll have a set of brackets, bring down the 2, the 500, and put a multiplication sign in between. 2 times 500 is 1,000, and log base 10 of 1,000 is 3. Because log base 10 1,000, using our scorpion tail method, equaling 3, can be rewritten as 10 to the power of 3 equals 1,000, which is true. So if we had log base 10 of 1,000 equals x, we would say 10 to the power of what equals 1,000? Well, it would be 10 to the power of 3 equals 1,000. So the answer is 3. Of course, you can just put this into the calculator and straight away get 3. So 10 to the power of 3 equals 1,000. Evaluate log base 5 of a fifth. So now we're going to use the second law of logs, which states that divide becomes minus, but we're going so we have log base 5 of 1 minus log base 5 of 5. So the divide becomes minus, and the numerator must come first, and the denominator must come second. So log base 5 of 1 is 0. Then we bring down the minus, and log base 5 of 5 is 1. And 0 minus 1 is minus 1. So log base 5 of 1. Well, if log base 5 of 1 was equal to x, we would say 5 to the power of something gives us 1. And 5 to the power of 0 gives us 1. So log base 5 of 1 becomes 0. And we actually know that from one of our laws of logs, which states that log base a of 1 is equal to 0. So it doesn't matter what the a is, what the base is. If we have 1 here, then we're always going to end up with 0. And then log base 5 of 5 becomes 1, because log base 5 of 5, if it was equal to x, we would say 5 to the power of what gives us 5, and 5 to the power of 1 gives us 5. So log base 5 of 5 becomes 1. And again, we know that already from one of our laws, which states that log base a of a is equal to 1. So if our base and our argument match up, then it's always going to equal to 1. Evaluate log base 8 of 16. So if we were to say 8 to the power of what gives us 16, well, that would be very hard to do in our heads. So what we actually want to do is change the base. So log base 8 of 16, we're going to rewrite as log base 2 of 16 divided by log base 2 of 8. And we got that from our change of base law, which is law number 5. And we did this because 16 and 8 can be written as powers of 2. So let's have a look first of all at how we got this. So the 8 is the a, is the base, and the 16 is the x in our formula. And we want a base of 2, so we end up with log base bx. So we're going to make this become 2. So therefore the argument has to go in the numerator. So we've got 16 here, so we've got log base 2 16. Then we have divide, and then we have log base ba, so our new base that we've chosen, which is 2, and the a was the original base. So log base ba becomes log base 2 8. So log base 2 16 becomes 4, because 2 to the power of 4 equals 16. And log base 2 8 becomes 3, because 2 to the power of 3 equals 8. So we actually end up with 4 over 3. So although we could have just put this into the calculator and got 4 over 3, it is important to be able to work these out in our heads. And having a base of 2 is very, very handy. So log base 8, 16, we rewrote as log base 2, 16 divided by log base 2, 8, and we got 4 over 3. In a similar way to the last question, we are going to rewrite log base 9 of 3 as log base 3 of 3 divided by log base 3 of 9. Because again, having a base of 3 is very handy. So base of 2 or base of 3 are handy logs to have. So again, we use the change of base law to do that. And then log base 3 of 3 becomes 1, because 3 to the power of 1 equals 3. And log base 3 of 9 becomes 2, because 3 to the power of 2 equals 9. So we end up with a half. So log base 9 of 3 is a half. So alternatively, we could have rewrote log base 9 of 3 as log base 9 of 9 to the power of a half, because 3 is the same thing as the square root of 9, and the square root of 9 is the same thing as 9 to the power of a half, which again gives us 3. So we can rewrite that 3 for 9 to the power of a half. It gives us the same thing. And then using law number 3 of our log's laws, we can bring that power down in front of the log. So we end up with a half times log base 9 of 9. And log base 9 of 9 is 1. And a half of 1 is a half. So we get the same answer either way. Evaluate the natural log, so ln, the natural log of e squared. So we're going to use law number 3, and we're going to bring the power down in front of the log. So natural log of e squared becomes 2 times the natural log of e. And the natural log of e is 1, because the natural log of e is the same thing as log base e of e, which is equal to 1, according to our fourth law. Log base a of a is equal to 1, so if our base and our argument match, we just get 1. And 2 times 1 is 2. Evaluate the natural log of 1 over e, or 1 divided by e. So we're going to use law 2, which states that divide becomes minus. So the natural log of 1 divided by e can be rewritten as the natural log of 1, so the numerator, minus the natural log of e, the denominator. The natural log of 1 is 0, because natural log of 1 is the same thing as log base e of 1, which is equal to 0, according to this law. So natural log of 1 becomes 0. And the natural log of e is the same thing as log base e of e, which is 1, according to this law. So we end up with 0 minus 1, which is minus 1.